What's up, everyone? I am back with another video. Looks like this could be a repair video. Um, so this is a HP 8654A signal generator, 10 to 520 megahertz. I heard somewhere that this was the first signal generator that HP put out that was all transistor based. Correct me if I'm wrong there, but that's what I heard on the limited research that I've done on this guy. But the reason I got this guy is because I am trying to finish up a repair on my HP 8557A with the 182T mainframe. I've done a couple videos on this. We've fixed the front end. We did the switch contacts, the finger contacts that tend to go bad with these. Here's an example of one. Well, this is what material that I used to repair them. This finger stock looks very similar to the originals, and replaced the where I left off with this one was repairing the tuning pot, and that was done, but ran into a new issue, or one that that we hadn't got to yet, and it's part of the operator's check with adjusting the log lin calibration, the relationship between those, and the reference cal adjustment, and I couldn't get it to work. And so my thought was, it's going to require some performance tests and possibly some adjustments if there's nothing wrong with the hardware, but I needed some additional tools to actually verify that, and some of those tools include this signal generator and this step attenuator. Step attenuator appears to work fine, but ran into a problem with this guy. So before I started using it with the HP 8557A, I wanted to verify that its output level was accurate, because that's going to be very important if I want to use it to calibrate that instrument. And so, to do that, I guess there's a few ways you could do that. You could use a power analyzer with a power sensor, which I don't have. But another quick way would be to just verify, because this output level also shows it in volts RMS. And so you could hook that up to a scope and check that. The problem is this guy is only working in one range, and that is the 250 to 520 megahertz range. So, for example, you can see here we've got a nice sine wave. Looks great, right? And you can see that RMS is roughly 2 millivolts. And so for this setting, we should be at 0.3 volts. Oh, sorry. Got the input attenuator on. Okay. Now that we have that at 0 and at the output level of 0 dB, we should be looking at 0.3 volts or 300 millivolts, and we are only getting 200 millivolts. Now, you could be saying, well, this thing must be inaccurate, right? Not necessarily. The problem is that at 250 megahertz on a scope which has a bandwidth of 500 megahertz, that's 50% the bandwidth. And once you get above 30% of the bandwidth on a scope, the response starts to roll off. So that could be what's going on here. And so if I want to verify the accuracy of this guy, I need to look at a lower range. But watch what happens when I adjust this range to something lower. That's pretty cool how this rolling type display. But look at that. The meter just went down to 0, and we have no signal. And that is true for all of the ranges. we get nothing. Alright, so it's back to 250, we get a nice sine wave. We should be seeing a sine wave like this, same amplitude for all of these ranges, and we're not. So something's going on with this guy, and we need to figure that out. I was thinking, well, maybe I could use just the 250 megahertz setting to run the calibration, but because I can't actually verify the accuracy of this guy, I thought that would be a slippery slope. So we're going to have to open this guy up, take a look at what's going on. My guess is it's very likely an issue just with this switch, but we got to open it up and figure it out. And this is how I end up with a bunch of unfinished projects. Like, I've got this scope down here that I wanted to do a calibration on. So yeah, that scope I wanted to do a calibration on, but I needed to calibrate my leveled sine wave generator, which requires a spectrum analyzer. So you can see how that snowballed real quick, and it's continuing to snowball because now we need to work on this guy. But I'm hoping this could probably be a quick fix, probably something to do with the switch as my first guess. But let's open this guy up, take a look, and see how far we get. Okay, so not the most user-friendly thing to take apart, but we did get it out. This is where I'm going to focus. So this is the assembly that you are able to tune the what frequency you'd like, and this switch is the switch that changes the range. Alright, so you've got a series of worm gears here. So you got this gear back here that turns the whole thing. You can see right there. So if I spin this switch, it'll spin this gear, which will then spin that gear to turn this guy around to the next setting. And then you've got your needle on this band here. So yeah, very interesting. And then this is the tuning this is the tuning knob here. Alright, so it looks like what we're going to have to do is remove these screws to get a closer look at the switch assembly for the range settings. Wow, so this is pretty incredible what they've got going on here. I mean, look at this wheel. So this is for each range, and you've got contacts here that are making contact with some more contacts down there. You can just see them, and if I put this guy right in between, look how tarnished it is. And this one right here is your 250 to 520 megahertz range. All these other ones here are the other ranges that aren't working. And it does look like they are barely making contact. Okay. So that appears to be the problem. It's not as, at first glance, it's not as annoying of a switch assembly as you know, some other switch assemblies on this older equipment I've worked on, but I could be wrong as we get more into the thick of this thing. But I think the easiest thing to do would be to clean up these contacts. We could work with this for sure. So that's what I think the problem is that these contacts on the other ones have worn, and or the springy contacts on the other assembly here are also losing their springiness and just not making as good a contact with all the others as these are. Alright, so did a couple things. I filed down those springy contacts right here, very gently. Didn't want to apply too much pressure because I didn't want to break them. I did try to bend them a little bit outward, but again, you know, this thing is probably almost 50 years old, maybe, and I didn't want to break them. So what I decided to do as well is add a little ball of solder to each of these contacts. And with that, I think I'm going to try putting it back together and see if it makes a difference. Well, I got this setting that I need working, and the amplitude is accurate. You can see RMS 1 volt. I left the output level at the highest setting of 10 dB, 1 volt, but now I've lost all of the other settings. Look. So, yeah. That's unbelievable. Oh man, it's definitely something to do with those contacts. So, all right. So I'm wondering if this is just a matter of that green wheel, if that could just kind of be repositioned or something. Because if I just hold this a little bit, then it works. If I hold it past where it locks in place, it'll work for each setting. So if we go to the 250, yep. So that might be something to consider. Maybe we can try that. All right. So it appears that there is a way to reposition or realign this wheel. There's one set screw there, and you've got another one over there. Looks like that's all of them, so that's what I'm going to try. Because you can see, this guy is kind of, it's a little bit askew there, and that's probably what's causing our issues. Alright, that was a bit of a nail biter. Those set screws were almost stripped. And it almost, either somebody stripped them, or it looks like the set screws for the knobs are, you know, SAE, whereas these set screws appeared to be metric, again, unless somebody stripped them. You don't need to tighten these, over tighten these, especially when you've got two. You know, so you don't need to go crazy on tightening these set screws. So somebody clearly did at one point. But look now, you can see we got it much more aligned. Yeah, that looks much better. I'm gonna check just again to make sure each of them is making contact, and then we'll reassemble and test again. I think we got it this time. So we're at 18.6 to 35, 24. Okay, it's a little off as far as the frequency, but not. There you go, 10 to 18. That's looking nice. There's 250. Check that out, looks good. And again, you're going to see that decrease in amplitude because we're starting to, we're above 30% of the bandwidth. So that's, what are we at here? 169, 170. Same thing there. And now you can see, look at that, the amplitude has increased. Ooh, that doesn't look very pretty though. Don't like the way that looks. That's the 66 to 130. actually. This is 35 to 66. That also doesn't look too pretty. It looks better than the other one, but not the prettiest sine wave. That's my first time seeing that, but amplitude looks good at 1 volt. Now see, that's much better. That's our 18.6 to 35 range, which will be the range we're going to use for the spectrum analyzer. And look at that one. Look at that. That's accurate. Very nice. The RMS is pretty much at 1 volt, which is perfect. We're at 10 dB. That's where I left it. So I left it at the max, so I would know to put the knob on properly. But that's perfect. But this thing looks like it has some calibration in its future for these other settings. That looks pretty good. Not, again, it's a little, something looks a little, okay, that looks a little better. I would imagine you would even be using a spectrum analyzer potentially to calibrate this guy for the peak shape, maybe. But anyway, we have all the ranges. So this thing, for the purposes of what we need it for, is back up and running, which is great. Once I get it back together, though, we'll go through the other output levels, make sure they're accurate, and then that'll be a wrap on this. So awesome. All right, we are all back together here, and let's just make sure that we still have all the ranges. Okay. All right. Good. 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 Okay. Now, let's do the accuracy test for the amplitude. And we'll do it at what setting we plan to use it for, which is 30 megahertz. Okay. Now we'll put the veneer up to 10 for 1 volt. And there we are, sitting at 1 volt. That looks good. Now we're gonna go through each range, and this will be pretty straightforward because we've got what it is in RMS right there. So now this is 0 dB, and I believe to do this properly, you should set from this to 3, and check that out. We're looking great. So that looks good. And next would be -10. We'll go back up to 10 here on the scale. And check that. Yeah, 100 millivolts. Perfect. Let's do -20 dB. Bring this back down to 3. Okay, and we'll bring this down, and we're at 30 millivolts. Perfect. And look, we're not going to go through each of these, but we'll go through a few more. Alright, so this is -30, which is the same amplitude as the same output as the calibrator signal, and we're sitting pretty at 10 millivolts is what we should be at. Yeah, this is great. -40. Okay. And we're at 3 millivolts. Again, really good. Let's just do one more. Let's go to -50. So this is 1 millivolt. And we're kind of pushing the limits of the, well, no, we're not quite there yet, but this is 1 millivolt per division. And we're at 1.2 millivolts. Alright, I said we were going to do, this would be the last one, but let's just do one more. We'll go to -60. Because now we're pushing the bounds of the scope. Yeah, that's... Yeah, so now we're pushing the bounds of our scope, starting to lose accuracy, but I think this is going to be perfect for our needs. Should be at 0.3 millivolts, and we're getting 700 microvolts. So, but you know, I think that's just due to the scope. Not so much this. I could be wrong, but you know, awesome. So we're in good shape. This thing's ready to go. Now again, I won't be done with it completely. It probably needs a calibration for each of those settings that the sine wave, excuse me, didn't look too pretty on. And you could see actually on that green wheel there were also adjustment screws at each at the top of each spoke on the wheel, sort of, and those were probably for adjustable inductors, possibly, to kind of tune that the shape of that sine wave. I'm guessing. I haven't read the manual too much on this because as soon as it started acting up, I was pretty confident it was that range switch that was the problem. So I didn't think this was going to be anything that would require a bit more of looking at the schematic. But yeah, this was an easier repair. Kind of needed that because now it was gonna, if it wasn't, it was gonna definitely hold me up to work on this guy, and now we can go through some of these tests that require a signal generator. All right, I hope you guys found that interesting. You know, a bit of an easier repair, but still pretty cool to get a look at the internal mechanisms that control the range, how they did that, and then using a real, you know, it's kind of similar, pretty similar to you know, a heterodyne radio. So yeah, really neat. But if you guys have any feedback, as always, leave it in the comments, and I'll catch you guys at the next repair. All right.